Hi, my name is Matt Erdman. I am the head TA for ME348. I have a lot of experience working in this lab as a TA under the precursor to ME348, which was ME345. Obviously doesn't exist anymore. It's transitioned into ME348, but I have a lot of experience working under that course number. So a lot of the equipment is the same. Some of it's different. Some of it we kind of revamped the procedures, stuff like that. So I look forward to sharing all that with you. What we'll be doing in these videos is we will be working through part 2 of the lab. So part 2, you had the option to either do in person or do virtually. Obviously, if you're watching this video, you chose the virtual part. So I will be walking you through how to use all the equipment, kind of making some intentional mistakes, sometimes probably not some intentional mistakes, and trying to kind of work through the labs, giving you guys a feel for it. Also, we'll have obviously any data that I collect posted to Canvas. So let's get started. So here we are going to be working on the oscilloscopes and function generator section of Lab 1. So obviously, since you did the pre-lab, you know that this is the function generator, this is the oscilloscope. Some of this is going to cover the same material that you covered in the pre-lab. Some of it's going to be different. So first thing you want to do, obviously, is turn it on. So the power button's here, and for the oscilloscope, the power button is actually up here at the top. You can press it in. So you also note that when you come into the lab, sometimes these would be hooked up for you. In this case, it is. So you can see that the function generator is hooked up to a splitter, which one end of which is going directly to the oscilloscope into channel 1. The other end will actually cover in a little bit, but what's going on there is it is hooked up to our DAC. So it is outputting our information to our DAC, which is another section of Lab 1. So what we're going to do now that everything has loaded up, let me make sure that that stays out of the way there. So let's just review some basic things. So first off, I'm going to zoom in on this function generator. All right, so this is a close-up of the function generator that I was obviously just talking about. So basically, I'm going to go over what all these buttons do. You should already have completed this for the pre-lab, but just to reiterate it, here are your knobs that adjust the frequency, the coarse knob or the fine knob kind of adjusts the frequencies that displayed here. Over across here is the range setting. So basically, this will get you in the general area in which you want to read the frequencies. Make sure that whenever you're reading the frequencies that you pay attention to this little red dot here. So this is actually 107 kilohertz instead of just 107 hertz. This up here, even though you can see these numbers, are not multipliers. So they don't multiply it. So this is not 107 times 100K. This is just 107 kilohertz. So this is not a multiplier, it's just a range setting to get you in the general range. Obviously, you can adjust the type of function by hitting these waves over here. You also can adjust the amplitude by twisting this knob. The offset and the duty knobs are right here. So this is the offset knob and this is the duty knob. I will note that in order to use them, you actually have to pull them out. So I'm going to show you this more when I'm zoomed out so you can actually see what the oscilloscope is showing, because the only thing you can really see from the function generator is the frequency. So you can't really see what these amplitudes, offsets, and duty knobs are doing, but you can actually pull these offset knobs out. And that's actually what you have to do in order to make that switch. Is in order to twist it, it'll twist if it's not pulled out, but if it has to be pulled out to actually be changing the signal. Obviously, this is the output knob, so it will be outputting it directly to the oscilloscope, like I mentioned earlier. So let's take a closer look at the oscilloscope. So this is the oscilloscope. Obviously, it has a whole bunch of buttons. Right now we have a really ugly looking picture. What we're going to try and do is we're going to try and fix that manually. Obviously, if you guys did the pre-lab, you'll know that hitting this auto set button will actually really fix things for you. So what we're going to do first of all is kind of adjust and play with it. So this right here is the vertical scale knob. So as we adjust this, it's making that scale higher or lower, so it's kind of zooming in and out. It is important to note that anything on this oscilloscope is not really affecting the signal other than input impedance, which we'll cover, I think, in lab 3. But if you're trying to change the signal, as you change this, obviously down here in this corner, the voltage is changing. But what that voltage actually means in this position right here is how big each square is. So about 5 tick marks, about the size of my pointer finger right there. So each square is 5 volts. So we're changing what that is by twisting this knob, but we're not actually changing the signal. The only way to change the signal is to use the amplitude button on the function generator. So we got it pretty much centered there with the scale. It is centered, so in theory, if we wanted to move it up or down, we could use this position knob. Again, this is not actually adding any DC offset. So the only way to actually add DC offset is to use the function generator. If you look over here, there's a little 1 in the corner, and so that actually indicates the origin of signal of channel 1. So if you note, as you change this position, the origin is moving with it. So you're not actually changing the signal, you're just changing how it appears on the screen. So this is still kind of bunched up, so what we would do is we're going to use the horizontal scale. So as you twist in one direction, see, I made it much worse, so obviously I would know to go in the opposite direction. So I can keep doing that. You'll note that the number down here, it says 5 microseconds right now. That essentially is the division on the x-axis. So each square, about the size of my finger, is 5 microseconds. So that's how we adjust that. That looks pretty good. Just out of curiosity, what we can do at this point is actually hit the auto set button and see what it thinks would actually be the correct answer, which was basically what I had there. It might have centered it a little bit more. We can read, the advantage of hitting the auto set button obviously is that these peak-to-peak values and frequency that we talked about in the earlier lab videos, but so those show up. So sometimes if you're messing around with other things, so if you hit, like, for instance, channel 1, those aren't there. So the only way to get those to appear really easy is actually hit the auto set button. That's when those will appear. If we wanted to measure things, what we could do is we can hit this button, measure, set some of these to what we want them to set. But obviously the easiest way, it's actually already set for you, but if you hit the button next to it for frequency, you can change it from channel 1, you could change it from frequency. We're going to cycle all the way around and hit frequency as well. It's kind of sticky. These things kind of move a little slow, so you want to make sure you don't pass it, because that's actually what I just did right there. So we have frequency showing, you can hit back. That's how it was, but so channel 1 frequency with the frequency reading right there. We also have some like trigger menus and stuff like here. So if you hit this trigger menu, basically this type edge means that it's at the edge here. If we change that to a video or a pulse, it actually is more of a moving signal. So we really want it at the edge. If for some reason, if it was moving and you couldn't figure out why, actually the default, if you just hit the auto set button again, kind of accomplishes the same thing. It automatically defaults the trigger menu to a type of edge. So that's very useful. I will tell you that the auto set button seems an awful lot like this default setup button. So what I'm going to do is I'm going to press that button and kind of show you what's going on. First, I will hit the auto set button and pay attention to what the peak to peak is down in this corner. So the peak to peak for this reading is 18.6 volts roughly. So if you hit the default setup button though, it'll go through everything and you'll see that obviously it's a really bad look here. So let's hit the auto set button, and the peak to peak is actually 186 volts. So for some reason, these oscilloscopes, default setup is to amplify the signal by 10 times. And so you can actually see that by pressing this 1. So if we press this 1, we can see the probe, the 10 times voltage. And so we can actually hit the button next to that and cycle through. Now that's at 1x, so then we hit backs. There are 2 signals on this oscilloscope that at times we will use. So if you change the probe 1x voltage, anything in yellow is for channel 1. So if you use channel 2, it's actually at 10 times voltage. So this can really screw up your measurements because sometimes one of your answers is significantly higher than the others, and it's because you didn't adjust both of them. So whenever you hit the default setup button, that's kind of what you're going to have to do. So we hit the probe 10 times voltage. We cycle through. Again, it's a little bit of a delay, so it kind of cycled through and it actually went past 10 times. So I'm going to have to do it a little bit more slowly and get the attenuation 1x, hit back. It now has that blue line. So basically, since there's nothing coming into this signal, it reads all zeros. So if you just hit the 2, kind of disappears completely. And these, again, are blue, so these are all channel 2 information. You don't really want those, so if you hit channel 1, you can see it that way. So now we're going to show you a little bit farther away view that you can see how these 2 pieces of equipment interact with each other. All right, so now that we have a more zoomed out photo of this, we can kind of see how we can adjust things. So as you adjust this course frequency, you can see that the frequency is going up, and obviously there's more, since the time frame from here to here is always the same, basically set by how far each division is, which again you can read down here at this corner at 5 microseconds. So if it's always the same, if you up the frequency like I've been doing, obviously there's going to be able to be more frequency waves in that time period, so it's kind of getting all bunched up. So we can also adjust the amplitude. Again, the amplitude is not one that you actually have to pull out, so we can just adjust this. If we hit the auto set button before we do this, what we can actually see is there's a peak-to-peak value down here. Right now it says 14.5, so we can actually adjust that and go all the way up. So one of the things that's very common to make a mistake is to do this, and actually let me zoom back in for you for a second there. You can see it says 20.3, but it has a question mark next to it. That question mark means is that it doesn't actually know what it is. It's just outside the range that this oscilloscope can measure. So it says 20.3. Let's hit the auto set button and see with the correct range what it actually measures. So it actually measures 22.6 or 22.4. So it is very important that you don't ever have a question mark for reading those. So just keep that in mind. So if you move the offset button, I'm going to just twist that, the signal's not changing at all. So what's wrong here is I forgot to pull it out. So if I pull it out and twist it, now you can see it actually moving up and down. As I mentioned before, this little 1 indicates where the origin is. So if you're actually moving this offset button with it pulled out, the origin's staying the same, but the position on of the sine wave is actually changing. So this is converse to when you are just moving this this position right here and actually moving it up and down, right? So this is the vertical position. This is actually just moving that origin with it. So it's always important to keep that in mind. There is not a great way to measure the DC offset on the oscilloscope, but if you think about it, since a sine wave averages to 0 if it has 0 DC offset, whatever the average of this wave is should be what the DC offset is. So what we can do is actually hit this measure button, and since I had previously hit the default setup button, all of these reverted to none. So what I will do is I will change this to the type is mean. So I'll zoom in for you to see that again. You can't really see it well. That's the fault of the webcam not quite focusing. But anyway, so if the type is mean, you can see the value is of 0.2 volts, 240 millivolts, but that's pretty good. There's really not much DC offset right now. As you pull this out and change it, so I'm going to be changing that knob, obviously. Let me zoom back in so you can actually see what the value is. So obviously the value of it is physically changing. This is converse. I'm going to plug that in and not touch it. Is if you just are using this position, the value isn't really changing that much. You will notice that it's changing a little, but it's not nearly changing as much as it is when you do the entire thing. So basically why it's changing a little bit when you do this is that's just some errors with the oscilloscope, where it's kind of has to do with quantization error, which you'll cover eventually. It has to do with just how it's kind of reading it in. A difference of 0.1 volt really isn't that big of a deal when you're dealing with figures that, well, so each one of these is 5 volts, so this is at least 20 volts. I think before it was 22.4 or something. So a difference of 0.1 really isn't that big of a deal. So anyways, so going back to this, if you take a look at the duty cycle, pull this out, you can actually see it's kind of widening, changing the frequency, but also it is skewing it to one side. So that's kind of how we can measure that. Let me hit the auto set button, and you can kind of see it skew even more as I switch it more and more and more. So we'll push that back in. Once it's pushed in, it kind of reverts to normal, although you should know that the duty cycle actually changes whether it's pulled out or pulled in. The offset button only works if you twist it. It only really works if it's pulled out, whereas the duty cycle kind of works either way, and the amplitude really only works when it's plugged in. If you pull it out, it actually just kind of goes to 0 and doesn't really change too much at all. I guess it's changing very, very small magnitudes. So anyways, you have that plugged in. Again, the amplitude should be at plugged in when you're changing it. The offset pulled out. The duty, it doesn't really matter. Not that we use the duty that much, but you need to make sure that it's turned all the way to the left, or else you could get some weird distortions or readings. All right, so now that we've been playing around with all of these knobs and stuff, what the Part 2 lab actually asks for is a sine wave of 100 hertz, a peak-to-peak voltage of 6 hertz, and nearly zero DC offset. So we need to record the frequency displayed on the function generator as well. So the first thing we're going to do is adjust the sine wave. So it asks for a sine wave. I'm not sure if I mentioned this before, but you can adjust the type of these waves with these buttons up here. So we want a sine wave, so we want the one that's actually smooth. We want 100 hertz. So ideally what we're going to do is we're going to just go right to this knob, and we're going to switch it, twist it. And you note that even at the lowest I can get, is 11 kilohertz. So that's not good. So the way to fix that, obviously, is I am in the 100K range. I want to be down more near the 100 hertz range. So if I hit that button, you'll note that the oscilloscope went completely flat. That's because the frequency has drastically dropped. We're only at 11 hertz right now, so now we can use this knob, this coarse knob, and kind of change it up. And for the fine knob, to get it a little bit more exact, we can slowly twist it so that we get roughly 100 hertz. I'm not going to worry about that last 0.2. Actually, it's 0.1. So again, for the oscilloscope, it's not really showing. I can't really read too much on that. So if you hit the auto set button, before I do that, actually, it's very important to note that this is changing. I'll zoom in for you. So this is changing between 800 millivolts and 1 volt, which seems like a pretty big % error. And so basically what's happening is it is so zoomed out So there's not much of a change from here to here. That the quantization error, which again we'll talk about later, but basically the oscilloscope has certain resolutions, and when it's so zoomed out and can't really see all the waves or what's going on, it's kind of just estimating it to be this, and so it's only accurate to 0.2 volts. So it keeps jumping up and down there. Also, you remember that I didn't really touch the amplitude, right? So why is it only reading 800 or 1 volt, 800 millivolts or 1 volt, while I didn't really touch the amplitude yet, and it was at 22.4 or whatever. So basically, it can only read what's within this range, right? So it's only saying that the difference from here to here is roughly 1 volt, and since this time scale isn't great, it's not capturing a full cycle of the sine wave. So let me hit the auto set button and explain a little bit more what I'm talking about. So if you hit this auto set button, what we were really only seeing was this small little portion down here, or this little portion down here. Like it wasn't showing the full wave, and so it only was showing the change from one end to the other was 1 volt, as opposed to, we actually know, again, it's 22 volts. So that's kind of the best way to see that, is to actually, the best way to actually see that is to hit the auto set button. If you can't see the full wave, it's going to give you some errors. So that's similar to the question mark, only this time I didn't warn us with the question mark. So anyways, so let's zoom back out here. So what we do want is we want the amplitude to change down. We want 6 volts. So what we can do originally is we can try and do this, and you can see that this voltage down here, zoom back in, is going from 2 to 5, but again, that's not the voltage we care about. The voltage we care about is this peak-to-peak voltage, or if you hit the measure button and cycle through and set one of these to peak-to-peak, that's the voltage we care about, not this voltage down here. So we care about this voltage, not this voltage. If we're trusting this knob, it's changing that voltage, but not really changing that voltage. So why is that? Well, it's because for the function generator, you have to change the amplitude on it. You can't actually be changing things with this one. So as we change this amplitude, you can actually, I'm twisting this knob, I'll zoom back in so you can actually see what's changing. So I'm decreasing it. It's getting a little smaller. So what we'll do, once it gets down to roughly 6 or 5.8, we'll hit the auto set button again, and it'll kind of change the scale down here for us. The way, if we're looking down here at the peak to peak, it's 5.6, so we can actually go adjust that to your 6 volts. So again, as this number down here, this 1 volt, it was 5 volts. The higher that number is, the higher the error you have on your readings. So by zooming in and getting it, the full picture here, you're able to have less error on here and actually zoom it into to 6 volts, as opposed to, like, it was fluctuating from like 5.8 to 6 before. But now it's pretty steady. So again, having it utilize the full range of the oscilloscope really helps you get those readings. So the last thing it asks for is roughly 0 DC offset. So let's go all the way back here. So DC offset is roughly this knob right here. We can look at it by hitting the measure button, checking out the mean. Offset really only exists when you pull this out, so we can change this and slightly change it a little bit. It's very touchy, and so as we zoom in there, you can actually see that as I change it, the channel 1 mean is roughly 29 millivolts. That's so small. That's 0.02 volts. So especially when our signal is 6 volts, so that's rather acceptable. So what you're going to want then, obviously, we can change this channel 1 peak, channel 1 nothing, I guess, to the frequency to display it. Our frequency has been decreasing a little bit. That's just an error of the equipment. So this right here is what you would want to submit for the lab report. So this is your oscilloscope. It is showing that your DC offset is roughly 0, your peak to peak is roughly 6, and your frequency is 100 hertz, and it's a sine wave.